Oh, sorry. Okay. So, okay, 13.6 in your textbook regarding the planetary motion and as well mana pula page dia tadi. This one. Okay. 345 sorry, 347 energy consideration in a planetary and satellite motion, but we will only discuss until escape speed, but escape speed, yes. Tapi sampai mana sebenarnya your group sampai mana sorry, 13.6 kan, belum lagi kan, last kan. So rasanya tersalah. Okay, ini. Okay, so you can refer to your textbook 347 because my connection is not good. So maybe some of my explanation needs to be re-explained if you can hear my audio. But so far, can you still hear my audio, buddy sister?
Yes, madam.
Okay. So in this energy consideration in planetary and satellite motion, we're going to discuss basically regarding our energy, which is consists of mechanical energy. So we have our energy here refer to kinetic and as well potential, but again this potential more refer to what we call gravitational potential. So that's why you're having not only your kinetic energy equation, half mv square, but as well gravitational energy due to your gravitational force. So gm times another mass divided by the radius or the distance between the two masses there. Okay, and then if we bring the objects to the condition of in the planetary in terms of our universe. So let's say I have this object here. Again, we are using the same figure in 13.10 as a particle of mass m move from A to B above the Earth's surface, and the gravitational potential energy of the Earth, the particle Earth system change according to the equation. So kalau kita tengok, as I have this object A here, so I can calculate in respect to the initial energy at point A as for the gravitational energy and as well for our kinetic energy. And then as I move it to point B, where I have the final distance respect to this point B here, and as well the the kinetic energy. So as you can see, as I respect to this mechanical energy here, delta K plus delta UG, which is we need to indicate again initial and final final energy. So we group it in terms of their stage. Initial dengan initial, final dengan final lah. Okay, so again and again, as I mentioned about planetary motion, means that as you can see in the figure 13.13, we have again the concept of centripetal circular motion. Circular motion. As our object or our planet is moving with a certain circular path here, respect to the maybe our sun as the center. Okay, or any object here, let's say a satellite respect to the Earth mass. Okay, so we can calculate again our gravitational force here equal to our centripetal, which is F equal to ma. So A here is referred to your centripetal acceleration. So I kata apa, respect to the gravitational force, gmm divided by r square. So you have this equation, and then as I simplify this equation, we can have again back our half mv square. So kalau you tengok equal to gmm divided by 2r. Okay, so as this one is again refer to what we call centripetal circular motion. Okay, so daripada equation ni, madam masuk balik dalam equation yang respect to our gravitational force, initial dengan final. So you will have this equation. Okay, so as we respect to our conditions of circular orbit, so mean that we are respect to 2R here. But if we are respect to elliptical orbit, means that we respect to semi-major, which is 2A. So you can tengoklah soalan tu nak dia refer kepada circular orbit or we would like to use our elliptical orbit. Okay, ada soalan tak pasal these 3 equation or 4 equation, brother sister?
Madam,
Yes, saya.
apa beza circular orbit dengan elliptical orbit?
Circular orbit is, as you can see, figure dia 13.13 yang gambar ni. This is true circle. Elliptical means that you refer to that they have 2 focal point. So maksudnya kita panggil semi-major lah. Kalau you refer kepada pages yang awal-awal dulu. So kita ada condition. Media tak go through about semi-major because itu semua dalam maths. Cuma as I would like to highlight that previous dalam chapter 6 kita buat true circle. This one. Biasanya true circle ni macam satellite. Our moon. So dia respect kepada true circle because our earth as one point ataupun one center. But for elliptical orbit like your planet dengan matahari lah. So biasanya yang ini. With sun. So biasanya sun as one of the focal point. Biasanya planet we are using elliptical. Cuma dalam soalan kadang-kadang dia mention juga walaupun we have our planet is elliptical but sometimes ada soalan yang dia nak dia bagi instruction yang dia nak pakai circular orbit. So you can choose either yang ini 13.19 and then as well 13.20 lah. Biasanya kita respect kepada 13.19 because we for ideal case we respect that it was circle orbit. Okay, clear tak yang lain?
Clear.
So kalau satelit dengan bulan biasanya memang true circle. So kita terus pakai true circle kecuali untuk planet sahaja. Dia kena tengok soalan. Ada yang nak true circle, ada yang akan pakai elliptical. Alright, okay. So kita go to the example as I would like to now changing the orbit of satellite. So hari tu kita dah buat satu soalan dalam example je satellite mana soalan dia. 13.3. So now kita nak further the same example but now we change the orbit. Maksudnya change orbit ni apa? Apa maksud dia change orbit pada sister? Hari tu kita buat. Orbit ni apa? So kalau you ingat balik dalam kata apa satellite tu dia ada certain distance. Every point dia maksudnya ada dia punya height from our above the surface. So itu kita panggil orbit. So berapa distance dia itulah orbit dia. Okay. So kalau you tengok 13.3 hari tu kita buat dekat 350 km. But now I would like to change it to 280 km. Okay. So again we have a space transportation vehicle release a 4,470 kilograms of communication satellite. Why? In a circular orbit of 280 km from the surface of Earth. So you kena tahulah. Yang ini nilai apa? Ini ialah kalau kita punya equation ialah nilai H above the surface of Earth. So we have a rocket engine on the satellite boost into a geosynchronous satellite. Geosynchronous orbit. Apa maksud geosynchronous, brother sister? Minggu lepas kita buat, dua minggu lepas lah. Kita buat geosynchronous ni apa? Apa maksud geosynchronous ni? Again. Anyone? Kita tahu ni kena geosynchronous ni apa? Ya.
Remain coordinate remain same.
Okay, alright. Okay, remain maksudnya dia remain. Yes, you have the same remain coordinate same with the country that own it. Selain daripada tu, another itu baru 50%, lagi 50%. What would be the period? Apa period untuk this satellite? Kalau respect kepada bumi, nilai period dia berapa? Hari tu kita dah buat period dia mesti sama dengan bumi punya rotation. So bumi berputar berapa jam, brother sister? Complete revolution.
24.
So you have to have 24 hours. So dia punya orbiting dia, complete revolution is 24 hours for this satellite. Kalau geosynchronous. Okay, kalau planet lain, nilai dia lain lah. Okay, how much energy does the engine have to provide for this boost? So satellite dia ada engine sebab tu dia boleh orbit our Earth dalam masa 24 jam. Depends on the engine juga berapa. Okay, so kita nak calculate dia punya how much energy does the has the engine have. Okay, so first kita kena calculate balik what is our new orbit respect to 280 km. So tadi Maiden dah bagi tahu yang ini ialah H. So kita tambah dengan radius bumi. So you will get this value. Okay, so as we respect to the engine energy is referred to this equation. Delta E, which is your E final minus your E initial. Initial dekat mana? Initial dekat 350 kilometer daripada equation example 13.3. And then final dekat mana? Dekat 280 kilometer. Okay, you kena use yang inilah equation ni. Respect initial dengan final dekat mana. So as we calculate again, we will have our engine here is actually positive. Engine value dia untuk energy engine dia will be positive because final dia lagi besar daripada initial. So you will get about this value 1.19 times 10 power of 10 joule. Okay. So this is the condition for our changing of orbit. So maksudnya kita makin dekat dengan bumi lah. So 280 km ni lagi dekat dengan bumi. Okay. So kalau you tengok tadi equation ni lupa nak mention. Dia ada negative because this is gravitational force and as well we respect to the condition that we call attraction. So that's why in there negative negative E. Other question? Any further discussion about this gravitational energy? Gravitational energy through planetary. So kita boleh guna this equation for any of our object. Kalau satellite you can use this 13.9. Kalau you punya planet kita biasanya pakai 13.20 unless dimension biasanya kita pakai 13.19 juga unless dimension dia suruh pakai elliptical. So kita pakailah. Yeah. Any further discussion brother sister about this subtopic here? Clear? So yang ini example dia further daripada 13.3 tu initial dia. Final dekat sini. Okay, ada soalan? Clear? Senyap je, clear ke tak ni? My audio okay?
Clear.
Okay, sebab my internet say it was bad networking. Tak tahulah kat UAE. Okay, next we have our escape speed from Earth. So we have another condition or concept regarding when the object move away from the Earth with a certain initial velocity that achieve our escape speed of Earth, then the object will be no more have a tendency to be attracted back to the Earth. Maksudnya, when this object move with this value of escape speed respect to Earth, let's say, and then when it go to the outer space, dia punya condition ialah dia no more be able to be attracted back to the Earth. Because this is the condition yang kita panggil escape speed lah. Okay, so first kita nak tengok what is the mechanism. So basically, the object who would like to be projected upward from the Earth's surface, they will move like this one lah. Okay, so kita tengok. So initial, they start with a value of velocity here. Dia dah start, let's say your rocket ke, dia nak launching to the outer space and then dia memang tak nak, dia punya intention is not being attracted back to the Earth. Okay, so this is the condition yang dia kena buat. Okay, so initial, so means that the satellite mass and as well is initial velocity. So it moves directly vertically upward. Okay, and then when it start move, kata apa tu, outside from the Earth's surface or environment, and then after a certain distance, here refer to R maximum here ataupun H here, it will be no more be attracted to the Earth, and then kalau kat sini kita tengok dia punya final velocity dia equal to 0. Kenapa equal to 0? Dekat outer space is vacuum. So you can imagine what will happen to the rocket, brother system. So maksudnya apa condition ni dekat outer space, V final equal to 0. Apa condition yang kita biasa sebut V equal to 0 ni, brother sister?
Static. The rocket is static.
Yes, dia akan actually more static or more floating lah, because outer space we don't have any more respect to this maximum distance here. So basically it will be no more be attracted by our Earth gravitation. So means that it will be more floating or static. Yes. So final velocity will be 0. So means that kalau final velocity 0, apa jadi dengan kinetic energy kat sini? Apa jadi dengan kinetic energy kat sini, brother sister?
0.
0. Yes. Kat sini dia akan jadi 0. So you will have your kinetic energy initial kinetic energy change only refer to your initial velocity or initial kinetic energy. Okay. So again, I will respect to the equation of mechanical energy, K plus gravitational gravitational potential energy still. Okay, so kita respect pada equation ni. But now as you can see, my initial velocity I have here. Okay, and then this is my potential initial. And then this is my potential final. Okay. Walaupun Madam sebut tadi dia no more able be attracted to the Earth, tapi nilai dia masih ada, cuma terlalu kecil. Okay. So kalau you calculate makin jauh R, maksudnya nilai G nilai potential energy dia semakin kecil. Ada tapi terlalu kecil compare to initial. Okay. Tadi kinetic energy final kosong. So kat sini tak adalah. KE dia kosong. Okay. Final kosong. Okay, so from this equation, I simplify respect to, I would like to calculate what would be the initial velocity for this object when you would like to have escape speed. Kita nak respect pada escape speed. Dia nak buat berapa condition. Okay, when I simplify this equation respect to the gravitational force distance, satu yang dekat bumi, okay, satu dekat bumi maksudnya betul-betul kat bumi sini, RE lah. And then kalau dia pergi ke certain distance ni, R maximum, you have to plus with your RE. R maximum ialah H plus RE. So, Madam simplify. So, dapat V escape equal to square root 2 GME over RE. Ini untuk bumi dahulu. Okay, untuk environment bumi. Okay, so kalau different different planet, kita replace dia punya mass dengan dia punya radius sahaja. Okay. So this minimum speed we call it escape speed. Okay, so this escape speed is independent of a mass object. So it doesn't matter how masses of your rocket or how masses of your space shuttle, dia punya escape speed dia tak follow the mass. Sebab dia punya independent. So the result in independence of direction of velocity, and as we ignore the air resistance. So this equation kita ignore air resistance, but in real life you need to indicate the condition of air resistance. So siapa yang nak jadi engineer NASA tu, dia kena go deeper lah about the condition of air resistance later. Okay. So tadi Madam sebut kalau kita pakai dekat bumi, we are using mass of Earth and as well radius of Earth. But we respect to another planet, kalau you nak buat dekat Pluto ke, you nak buat kat Neptune ke, Uranus dan sebagainya, kita respect to their mass and their radius. So as you can see in this table 13.3, is the value of escape speed from the surface of the planet, moon and so on lah, sun. So kita tengok bumi tadi, berapa nilai dia. So basically the value of our Earth escape speed is about 11.2 km per second ataupun 11,200 meter per second. So this is the value for your rocket or for your space shuttle would like to be no more attracted by Earth surface bila dia berada di luar bumi. So this is the minimum value dia. So kalau you ada escape speed yang maksudnya kalau that rocket achieve this escape speed, dia maksudnya tak boleh ditarik balik ke bumi. Alright. Okay, so kita tengok one example here as we would like to calculate the escape speed of a rock. So we would like to calculate if we would like to throw the rock to the outer space. Okay, what will happen if it move with escape speed? Okay, so I have a Superman. So you can refer to example 13.8 here. Superman picks up a 20 kilogram rocks and hurls it into space. Superman. What a minimum speed must it have at the Earth's surface to move infinitely far away from the Earth? So another condition yang kita masukkan, there are no more a tendency to be attracted to the Earth is this condition. Move infinitely far away from the Earth. Okay. So again, we are using our escape speed equation. Tadi berapa? 13.22. Respect to the mass of Earth and as well radius of Earth. Kalau you tukar dekat planet lain, kena pakai planet tu punya mass lah. Okay, so value untuk bumi, mass bumi dan juga radius bumi. So, kita dapat dia punya nilai sama. 11,200 meter per second. Sama dengan table ni. So, kalau you nak lontar rock dekat outer space, you kena buat dia punya speed banyak ni. 11,200 meter per second. Okay, so that's all your chapter 13. So actually we already finished our syllabus discussion. Anything that you would like to highlight, brother, sister? Clear? Anything? Ada soalan tak?
Tak ada.
Tak ada lagi. Okay. So starting from next week, actually, I will have some of the class. I'm not conducted it onlinely. Maksudnya, you kena buat tutorial question, you kena buat latihan dalam website, and then ada a few sessions saja yang kita akan buat online as we will discuss our tutorial question, especially in the textbook. So please make sure that every single kelas yang madam tak buat kelas, you kena submit attendance through Telegram. So please make sure that submit your Telegram kan. Submit me your attendance. Okay. So kita nak saya.
Nak tanya madam, yang 20 kilogram batu tu tak ada ni tak ada fungsi dalam soalan ni.
20 tak ada fungsi, betul. Sebab tu tadi madam cakap dia independent with the mass. So tak kisah berapa masses objek tu, so dia independent. As long you boleh achieve, you boleh launch dia to the outer space vertically dengan this speed, then dia are no more be attracted. So kalau you nak pakai 2 kilogram pun boleh. Dengan syarat dia punya speed kena start dengan minimum 11,200 meter per second. Minimum. Kalau you nak, maksudnya kalau you nak pakai roket pun sama. So maksudnya you kena tengoklah mekanisme dia. Walaupun dia independent, tapi kena tengok mekanisme of kalau masses object, macam mana kita nak launch dia dengan 11,200 meter per second. Ini 20 kilo je, rock je. Kalau rocket, you means that you need to have a very good engine so that it can maintain 11,200 meter per second. So biasa tengok tak bila launching roket ni, akan ada a few tank akan jatuh. Pernah nampak? Pernah tengok tak launching of rocket?
Benar.
So dia ada beberapa komponen yang mana dia akan separate. After certain distance dia akan separate because dia nak keep kalau dia punya attention is to have escape speed lah. Kalau dia tak ada attention dia bukan untuk escape speed, biasanya dia ada certain mechanism lah. So siapa yang nak buat orang kata apa aeronautik dan sebagainya, you have to go deeper lah. Ini hanya untuk any masses. Dia punya kita kata apa basic of escape speed. So mechanism dia nak launching, you kena refer balik kepada your field lah later. Okay, clear tak yang lain? So tak kisah dalam kita punya teori ni mass dia independent. So you nak 1,000 kilogram roket pun boleh, tapi dia punya launching speed mesti minimum 11,200 meter per second on the earth surface. On the earth. Kalau dekat bumi tempat lain tak berani nak cakap lah, kena calculate balik. Okay. Dan kalau ikut betul-betul ni dia pun ada dia punya coordinate launching juga. Kalau siapa yang pernah buka dokumentari untuk roket, dia ada certain coordinate untuk dia launching with this condition ni. Okay. Further discussion, brother sister? Clear?
Yeah.
Alright, okay. So we have maybe 5 minutes break. We coming back with the discussion of our tutorial chapter 8 and 9 because next week we going to have our test 3 again in the Friday night session. So sama macam yang sebelum ni. So kita akan ada chapter 7, 8 and 9. So 7 dalam buku assign, 8 and 9 ada yang dalam chapter buku teks. Yang itu kita nak bincang sekejap lagi. Okay. So 5 minutes break, we coming back with the sharing of whiteboard. So I will call up a few names so you kena share your answer.